All right, AP World, welcome back, and thank you so much for all your hard work. Today we are going to start week 6, and that is going to be parts of the brain. Now, this unit, last week's stuff, also known as your nervous system, and everything you did while I was gone and just took a test on, which is mostly the nervous system, is very easy. So week 1 was hard. Bio Brain week 1 was hard. Bio Brain week 2 is pretty simple. Bio Brain 3 is really hard. It's really, really hard. It takes everything that you learned in the last 2 weeks and puts it all together and adds like a million more terms to it. So what we are going to do is we are going to diagram it out. You have no idea how sad I am that we are not doing this together because it is one of my favorite things to do. So I'm so sad. Okay, anyway, let's go. So first and foremost, you are going to draw what I tell you to draw, and you're going to do it as best you can. You're also not allowed to make fun of mine because I know yours is not going to be that good either. So we are about to draw 2 heads facing in opposite directions, but you need to have enough room to write it out because when it's done, it'll look like this. So when I say 2 heads facing the opposite directions, that's what I need. Okay? So let's get started. Keep in mind, be kind. I'm not there to defend myself, so be nice. I did fold my long sheet of paper that's in the front of the room, or should be in the front of the room, in half. So please do that now if you have not done it. So fold it in half, open it up, and then please draw your 2 heads. Oh gosh, it's going to be one of those days. This isn't good. Oh yeah. All I'm going to say, if you're making fun of mine right now, I hope yours is beautiful. Uh-oh. Oh God, it got worse. Oh, it did get worse. Oh, it got really bad. That's okay. That's okay. All right. Well, that's not good. All right, so what you're going to do is we are going to label it left and right. Please do that now. All right, so on your left side, you're going to draw just what I do. And then you're going to mimic it. Remember, oh gosh. This is awful. All right. So what we're going to do is we are just going to label it right off the bat. So this is your frontal lobe. This is your motor cortex. This is your somato. I'm going to zoom in now that I'm on this side, and that way you can see it. Somatosensory cortex. And this is your parietal lobe. This is your occipital lobe. And this is your temporal lobe. Now please write where I'm writing. There's a reason, I promise. Okay, so now that we've labeled all our parts of the brain, we're going to now label the other side. Now keep in mind, this is the opposite side, so they're facing other ways. So if this is the back, this is your parietal lobe. This is your somatosensory cortex. This is your motor cortex. This is your frontal lobe, which is way too small. Whoops. This is your temporal lobe. And this is your occipital lobe. All right. So now that we're on the right side, I'm on my right side, please be on your right side. What we're going to do is we are going to start labeling what the different parts of this does. So for your parietal lobe, I'm going to write skin next to it, because in your parietal lobe, that's where all of your somatosensory, that is where all of your skin sensations are being sent to in your brain. So your parietal lobe processes info from your skin, such as temperature and body position. So everything like that is all coming from right there. Okay? Now, your somatosensory cortex, this is going to receive info from your peripheral nervous system, or PNS, from afferent neurons. Okay, so what's going to happen is, of course, we've talked about atoms and neuron fires, dendrite, soma, axon, soma, nucleus, axon, myelin sheath, axon terminal, terminal buttons, all that stuff. When that information goes from your peripheral nervous system to your central nervous system, up your spine and into your brain, it immediately goes straight to your somatosensory cortex. So when we keep saying the central nervous system is where your afferent neurons go, they actually go to your somatosensory cortex. Once they're in the somatosensory cortex, the inner neurons inside your somatosensory cortex and figure out what is happening and figures out what to do next. So instead of saying, well, it's the brain that's going to figure it out, it's now the somatosensory cortex. Inside the somatosensory cortex, different parts of your peripheral nervous system are picked up at different parts. With those different parts, it processes, goes through, and then it sends what it needs to. It sends that information, your inner neuron sends the information to your motor cortex. Now your motor cortex receives info from the somatosensory cortex and responds with efferent. I'm just going to underline my A and underline my E to stress that. My efferent neurons to the PNS, or the peripheral nervous system. Okay, so your somatosensory cortex receives information from your peripheral nervous system, processes that information, figures out exactly what's happening with the inner neurons, then sends the information to your motor cortex. Then the motor cortex then sends that information down your spinal cord, back through the peripheral nervous system to whatever muscle it's trying to move. So the reason why they're right next door to each other is that they're in constant communication with each other. So information comes up to the somatosensory cortex. The inner neurons inside the somatosensory cortex are going to process that information. Then it's going to give that information to the motor cortex, and in the motor cortex, the inner neurons are then going to decide what to do and then send those neural impulses into the peripheral nervous systems to punch me in the face, walk, whatever I need to do. So your somatosensory cortex, afferent neurons, receives all your sensory neurons, while your motor cortex sends out your efferent neurons, or your motor neurons. And they're right next to each other because they're in constant communication. All right. Now, the very front is the frontal lobe, also known as the newest part of the brain. Every time I think of the frontal lobe, I think of monkeys have a very, very, very small frontal lobe. Dogs have even smaller. In your book, you have a really interesting diagram, and it's also in this week's PowerPoint that I'll bring up, that show you how developed other animals' frontal lobes are. And you'll see that they're very, very small, which is why when I show you the humans ones, which is how big it is, you'll see why humans are able to text, make up things called the internet, have a government, do all these different types of things, because our frontal lobe is so much bigger. So every time I think of something, whether does the frontal lobe control it or something else, if a human is the only one who can do it, it has to be done by the frontal lobe. Okay? Dogs have emotions, dogs can run, fish can swim, physical movement, every animal can do it. If it is something a human can do, it can only be done by the frontal lobe. So, in order to distinguish that, we call that higher mental processes. Okay, and what are higher mental processes? They are everything that makes us human. So if a human is the only one who can do it, then it has to be done in the frontal lobe. There's no other place. So things that humans can only do, decision making. Now you're probably saying, well, my dog makes a decision to either eat or not. I'm talking about like real decision making of like weighing pros and cons. Dogs, if there's food in front of it, the dog's going to eat it. From personal experience, the dog always eats it. However, for us, even if we see a apple on the ground that has been stepped on, we're not going to eat it, but my dog would. So that's the type of decision making. We don't always have to do the same things. Production of speech, we are the only one who has a full vocabulary with a full language spiel. Now you're probably saying, well, Miss Bennett, whales can talk to each other. They're talking in sounds, it's not speech. They're not making up words. They are connecting and communicating just like dogs when they bark, but it's not a full speech. I'm sorry if you're disappointed to know that your dog is not singing its song of its people every time it barks. It's just making simple commands or simple requests, not a full-on conversation, and of course planning. My dog has no idea that dinner is coming. Every single day I put out food, it's like the first time he's ever seen it. He's not budgeting his calories for the day. He's living life. Planning is a human thing. So, things that make the frontal lobe and how I always remember the frontal lobe, it's the newest part of the brain. So if humans are the only one who can do it, then it has to be from the frontal lobe. Humans are the only ones that can text. Humans are the only ones who can play piano. It has to be done in the frontal lobe. Okay? All right, so your temporal lobe, okay, how I remember it, temporal is music, whether you have fast music or slow and beautiful. That's the tempo of music. Tempo is your hearing. And inside your temporal lobe, you have your auditory cortex. Your auditory cortex is where all of your sounds are being processed. So right now you're hearing my voice. Your auditory cortex is the one processing that information and sending that information along. So the fact that you hear me saying hello, your auditory cortex is picking up the sound, is processing that sound, and then sending it onto the brain so your brain can process it and then understand, oh, she's saying hello. Now the temporal lobe is pace of music, tempo. It's also located right by your ear, which makes sense because why would you have your auditory cortex at the top of your brain if your ear is on the side of your brain? So they're located on the sides right behind your ear to make it easier for it to process. Okay, so your auditory cortex is located in your temporal lobe, and your temporal lobe is used for hearing. Now your occipital lobe holds the visual cortex. Now, every single one of our senses, our hearing, our sight, our touch, okay? Our taste is going to be behind our nose, which we won't get to that until next week, has a cortex. Your visual cortex is in the very back. The reason why it's in the very back of your brain, it takes up so much room. We depend on our visual much more. Our visual senses much more than anything else, which means it takes up a lot of room. So we ran out of room in the front, so we might as well have it in the back. Also, every animal can see, except for the ones at the very bottom of the ocean. I'm aware, but they have some sight. Don't even get me started on that. Okay? However, most animals can see, which is why it's in the very back of the brain, because it's of the old. Okay? So, parietal lobe, skin, occipital lobe, visual cortex, temporal lobe, hearing, somatosensory cortex, motor cortex, okay, and frontal lobe. All right, so those are your basic functions. On your left side of the brain, which is where I'm shifting now, we are going to add a couple of things. Now, there are some associated areas. in your brain. And associated areas are where we're not 100% sure everything happens there. We can't pinpoint it, but we're pretty sure information of a specific sort is processed there. Remember, not all psychology is laws, most of it is theories, and this is a theory. So, in your frontal lobe, we believe that there is an area or an associated area called Broca's area. Now, Broca's area is in your frontal lobe, which means it has to be something that humans can do that animals can't. And this is language creation. Broca's area does all of our language creation. So the fact that I have words in my head and then I'm getting them out, sometimes more articulately than others, it is where it's being done. It is the physical creation of language. Now remember, animals cannot physically make a language. So because they cannot physically make a language, it has to be located in the frontal lobe because we can do it. How I remember it and what I suggest for you, broca, broken jaw. Okay, broca, broken jaw. If your jaw is broken, you can't make words. Okay, broca, broken jaw. If your jaw is welded shut, you can't move your mouth. And if you can't move your mouth, you can't make words. Broca's area. I know it's not perfect, but whatever helps, right? All right, your next associated area is in your Wernicke's. Now keep in mind, I'm only doing this on the left side, and there's a reason why. So in your temporal lobe, you have Wernicke's area. Now Wernicke's area, and I'm going to write it way over here. If Wernicke's area. Now, this is not in the frontal lobe, which means animals can do it as well. However, this is used for language comprehension. Now, why is it in your temporal lobe? Well, to be quite honest, it needs to process all the information you're giving it and providing, of course. Why have it in another part of your brain if it needs to be processed immediately so we can have a conversation? It might as well be next to the ear. And even though animals do not make language, they do have sounds that they interact with one another with, and it needs to be processed quickly, which makes sense that their language comprehension or noise comprehension is by their ear as well. How I remember it is Wernicke. When people don't understand what you're saying, they say, Wernicke, what? Language comprehension. So that's how I would remember it. So when people don't understand what they say, what? So Wernicke, what? Language comprehension. Okay, so those are your associated areas. Now your associated areas are only located on the left side of your brain. The reason why they're on your left side of the left hemisphere, your left hemisphere is in charge of only a couple of things. Both sides of your brain has certain responsibilities. Your left hemisphere is in control of language, logic, and linear thoughts. Okay, hopefully you've noticed your left hemisphere is controlled of language, linear, and logic. All else. So if it starts with an L, it's probably on the left side of your brain. Isn't that lovely? Oh, it's wonderful. Okay, now language is dealing with comprehension, and creation. Okay, which is why creation, which of course is your Broca's, and your comprehension is your Wernicke. They're only on your left-hand side. Logic is your reasoning. So your math, I'm going to put it in parentheses skills. If you're strong in math, you're typically more left hemisphere. And your linear thoughts are thought progression, and understanding. Okay? So, when you think of left hemisphere, you need to think of language, logic, linear thoughts. Now, I've added a lot of information. We started with all of our different lobes and what they did and some of our cortex, and we added some areas, and now I have you responsible for that. It is important that you are keeping things separate. So right where I write, when you have a lobe, what that means is it's an area of the brain where information is processed. This is an area where just collectively, that's the only thing they're focusing on. So that's a lobe. A cortex, of course, is areas of sensation processing. So your auditory cortex is only dealing with your auditory or the sounds. Your occipital lobe is dealing with your visual cortex, and they're only dealing with the things you're seeing. Your parietal lobe doesn't really have a cortex, but it's dealing with all your skin. Your somatosensory cortex is dealing with all of your sensations, while your motor cortex is dealing with all of your movement. That's what they're doing. It's a specialty. And then you have areas. Areas are parts of the brain that are not specifically identified, but assumed to be occurring there. Okay, so we have lobes, we have cortexes, and we have areas. Hopefully that kind of helps you keep them a little bit separated for you. All right, now going back to your right hemisphere. Now, if your left hemisphere is in charge of language, linear, and logic, then your right hemisphere has to be in charge of some things too. Now, I will be honest with you, your right is not as pretty because it does not all start with R's. So anything that does not start with an L has to be your right, and that's kind of a nice rule of fun. So creativity is the first one. Feelings, and when we say feelings, you understand your own feelings and others. Like you're really good at picking up other people's emotions and stuff like that. Melody, if you are musically talented, so the ability to understand music and difference. This is absolutely not me. And spatial awareness. And this is control over body movements. Okay, so your right side is in control of your creativity, your feelings, your melody, and your spatial awareness. Okay, that's what your right hemisphere is in control of. Okay, so not as pretty as your left, but it does. All right, and finally, one of the big things that is connecting your parietal lobes, and this is the last thing we'll be drawing, is a major piece, and of course it doesn't really look like this in your brains, and hopefully this is not what your brain really looks like anyway. Is a piece called the corpus callosum. Now, the corpus callosum connects both hemispheres of the brain and allows them to be aware of the body's other activities. Okay, so the corpus callosum connects both hemispheres. So if you were thinking when I was talking about right and left that, okay, like for instance, for me, I am really good and I know who I am. Like I know what my feelings are. I'm always very clear of what I want and what I care about. I'm also very good at thinking about thought progression and understanding of things. I am a very good planner. I'm able to organize myself. And so I'm on both sides. It's your corpus callosum that allows you to be on both sides. Typically, people are more one side than the other. If I had to pick one, I'm probably more left than I am right. However, I would say I'm definitely more towards the middle than most people are. Your corpus callosum allows your brain to talk to each other. It connects the two hemispheres, so even though language is happening all on your left, it's the right is still having an impact and an involvement in things. So it's not a completely isolated component. Now, I'm pretty sure at this point class is going to ring. However, I would highly suggest taking a crayon and coloring in your regions, making sure they all match up. So if you're coloring in, for instance, green, your frontal lobe, you should be coloring in your frontal lobe over here green as well. So I would absolutely do that. This map that we're doing right now, that we completed today, is there as a resource for you. It is very good and very helpful. I know every year I do it, I always go back to it constantly because it's so helpful. It helps me keep things organized and settled up. When we get back to school on Monday with you, I will be then working on an actual diagram of the brain, and we'll be labeling things with much more detail. But this, I think, gives you a great way to kind of start the conversation of where things actually are and how things actually work. So when we're actually looking at a real looking brain with actual brain structures that, thank God, don't look like this, you will see how things kind of line up, and I think it'll give you a little bit more grounding and understanding of what is actually happening. So what I would do is, even if the bell rings while we are doing this, I would absolutely fill in your space so that way you can see it a little bit more clearly that you have the same things on both sides, except for, of course, your areas, which would be your Wernicke and your Broca's area, which are only on your left side because both of those have to do with language. Being able to distinguish what side of the brain, left and right, is absolutely on your test on next Thursday, and it is something that we'll keep coming back to throughout the year. When you come in on Monday, our instruction is going to be, like I said, on a brain, which is going to look like this, which is super, super helpful. As you can see, it's more anatomically correct, and we're going to do the back of it. And this will help you with your limbic system, which we just did not cover at all. And we'll kind of get that information going. So please make sure you color in your brain, whether you do it today in class or later. It just makes everything easier. So, all right, guys. Well, I'm just going to finish coloring in my brain here and coloring in my areas, and then I am done. I hope you have a wonderful weekend. Thank you again. This is a different purple, I hope. I hope you have a wonderful weekend. It's a little similar, so I'll have to break that up. I'll make this one really dark. There we go. Solved it. All right, guys. Just coloring in a brain here. No big deal. All right. Have a great day, and I look forward to seeing your brains. Please don't make fun of mine too bad. All right. Have a great day, guys. Bye.